but I'd like to revisit the course objectives. So our objective of this subject is to understand the object-oriented programming principles. Okay, we are going to study the difference. So in today's class, I'm going to talk about the difference about the C, C++, and how it is different from Java programming. Okay, and we are also going to get into some first basic program of Java. Okay, we are going to write a first program, Java program, and we are going to do it on some editor. And we will definitely then understand also the Java architecture of Java, why we call Java as platform independent. And then we get into the first basic constructs of the Java programming language, that is data types, variables, arrays, operators, so that you can use them and implement so
once as a revision maybe in today's class.
okay. So Java is a programming language and it is also a platform. Okay. So can someone tell me, let us keep this session little interactive, and can you tell me what is a platform? Can you think and tell me what is a platform? So I know that most of you are aware of what is a programming language, right? I need not ask that, but what is a platform? So I want you to write your answers in the chat box. So do not write it privately. You can write it to everyone so that we do not have repetitions of the same thing. What do you think is a platform? Yeah, platform is something where we can present something, okay, but platform from programming and computer, as a computer science engineer or in the field of computer science, what do you think is a platform? Where we run the program. Okay, right. So a platform is a combination of all the libraries and the tools that gives you a complete environment to develop and run your program. Okay, so platform is everything that is required to run your program. Now Java is a high level object oriented programming language. So why do we think that Java is high level? Why is this programming language a high level programming language? So object oriented, why it is called as that, definitely we are going to study in the entire class, in the entire course. But why it is high level? So you have to write the answers in the chat box. English words. It can be understood by us. Yes. So we are not writing the program in language which is understood by the machine. So we're not writing binary state numbers which, the instructions are not in the binary form, or it is not directly written in the assembly language or machine level language, right? So we write, Java uses syntax and the language which is understood by the human, okay? And that's why we call it as a high level programming language. Now, what is the difference between a programming language? So what is the difference in a high level programming language and a natural language? So natural language is something that we use to communicate with each other. So English is a natural language, okay? And that makes it different from the programming languages, that we have a fixed compiler, okay, for these programming language, a fixed syntax is there, and then, okay, that is there even for English. But I hope you understand the difference between the high level programming language and the natural language that we use for our everyday communication. Okay, so Java was developed by Sun Microsystems, which is now the subsidiary of Oracle. And may I know the father of Java? Who is the father of Java? So quick answers. Did you study about it? Have you heard? James Gosling. Yes, yes. So James Arthur Gosling, often referred to as Dr. Java, is a Canadian computer scientist who is known as the founder and the lead designer behind this particular Java programming language. Okay, so now let us go into the features of Java. So Java is considered to be, so we all know, right? First, if you look at the chronology, then it was first C, then C++, and then Java came, right? So Java is considered to be easy to learn because most of the syntax in Java is similar to the syntax of the programming language you have earlier learned, which must be C or C++. Okay, and in Java they have removed all the complicated things like pointers, operator overloading, which is there in other object-oriented programming language like C++. And in C++, you might also be you will be working probably in your data structures class that you will be using that delete method to dereference your memory allocated dynamically, etc. But in Java, this is taken care by with the help of an automatic garbage collector. Okay, so Java is a simple and easy to learn programming language. It is object-oriented programming language because you are organizing your complete software as a combination of different objects. So every entity is represented in the form of object, which has which is identified with help of some typical uh, data members and members and member functions that operate on those data members. So for example, if it is a bank, okay, so you are modeling a bank, then in that you create an object called as bank account, wherein you have how do you identify what are the characteristics or the features of an account. We can say that account will have an account number, account holder's name, the date of beginning of that account, the amount which is there in that account, and all these typical characteristics. So all these features together identify that entity, real life entity bank account. Okay, so whenever you are writing a program for it, you represent it in the form of object. Okay, and that's why we are organizing our complete program in the form of objects, and that's why it's called as an object oriented programming language. Okay, now there's another third feature of Java, that it is a concurrent, it supports concurrency. What does that mean? That a program can be divided and can be run parallelly by different cores on by multiple CPUs. Okay, so Java provides an environment for that, in which a program can be parallelly run on multiple threads. Okay, so all the memory management and plus even the programming language itself supports multi-threading. So that's why we say that Java is a concurrent language. Okay, so it supports multi-threading. Platform independence. Now this is a very important feature that and something that differentiates Java from our C and C++. Okay, so here Java is called as a platform independent language. So we are going to discuss this in detail in today's class. Okay, but why Java is called as platform independent is because the Java compiler converts a program which is written in a high level language, which is Java language, into a code which is called as a bytecode. Okay, and then this bytecode can then be run on any system, on any architecture. Okay, be it Linux or Windows or Mac, anything. So whatever the bytecode is generated by the compiler, it is not platform dependent. It means suppose today I am writing a code on my Windows machine and I convert it into a bytecode, okay, which is stored in the .class file. Then this .class file can be taken and run to some other platform. Okay, so this is not something which happens with your C or C++ program. So this is what makes Java platform independent. We are going to discuss this ahead in detail. Java is also architecture neutral. Now, what does it mean? It is architecture neutral means there are no implementation dependent features. Okay, so if you look at the other programming languages like C and C++, depending on what is the system architecture, the size of the int and the amount of bytes that it occupies changes depending on whether you are using a 62 or 32 or a 64-bit architecture. But in Java, for example, your integer will occupy 4 bytes in the memory in any architecture. Okay, so Java does not include such implementation specific features. Okay, so this is something which makes Java architecture neutral. Now Java is said to be a compiled and an interpreted language, both. So when the Java program is converted into a byte code, then either the Java virtual machine, which is called as the JVM, execute each instruction one by one, okay, by converting it into a machine code. So first instruction converted into a machine code and then executed. Second instruction converted into a machine specific code and then executed. Third instruction from the byte code converted into a machine specific code and executed. This is something which the interpreter does. Okay, it picks up an it picks up an instruction, converts it, and then executes. So this is the job of an interpreter. At the same time, Java virtual machine also has the Java runtime environment also has execution engine which has in Java just-in-time compiler. Okay, what it does is it picks up the entire program, okay, and then converts it into machine specific code, which then becomes similar to the way your C++ programs are run, and then the complete program gets executed, loaded in the memory and then executed. Okay, so we say that Java is both interpreted and compiled language. Now let us have a look at how C++ programs are written and executed. Okay, so suppose you have written a C or a C++ program on your laptop which supports Windows operating system. After that, you use GCC or whatever compilers are available. Okay, so what are the compilers available to compile your C++ programs in Windows? Have you tried any one of you? GCC is there in your Linux machine. What do you have in Windows? Can you name? Have you heard about SYGWIN, the software? No. Okay. So you are going to find it out for me. One, I have already mentioned. You are going to find out more what are the compilers available for Windows. Okay. So the compiler converts the program and into a machine executable code, which is on a Windows OS. It's nothing but a .exe file, right? Now this .exe file can be run on an executed started and it can run on a Windows operating system, but you won't be able to pick up that same exe file and run on a Linux or a Mac OS. Okay, so this is what makes the programming language platform dependent. Means what we say here is, what we observe is the complete source code gets converted into an exe file. This exe file is specific to Windows OS, and this cannot be directly picked up and started, and the running cannot happen directly on the other operating systems because this conversion is specific to Windows. This conversion is not independent of the underlying architecture or underlying operating system. Okay. Now let us look at the compiling and running of the program in Java. So you have written a Java program again on your Windows operating system. You pick up the Java compiler and then you pick up your Java compiler, which then converts your source code into a code which is called as bytecode. Okay, this is stored in a .class file. So whatever .java file you have written gets converted into a .class file, and this .class file holds is nothing but it is called as the code that it holds is called as a bytecode in Java. And then this bytecode can run on Unix, Windows, Mac, and any other architecture, and the output generated is same for all. Okay, so there will be a JVM Java virtual machine on Unix. There will be a Java virtual machine on Windows. There will be a Java virtual machine on Mac. And this Java virtual machine's job is to convert this bytecode into the machine, the specific system it is running on, and then that program gets executed. Okay, so write once and run everywhere. This is what Java follows, right? So you can write the code once and create the class file, which then can be picked up and run anywhere. Okay, so here why do we need to compile and create the .class file? Because if you do not do that, you won't be anytime assured whether the program is syntax free or everything, right? So you have developed on some system, okay, and then this executable is then passed on to any other platform where it can be executed and run. It need not belong to the same platform where it was, same system or same operating system architecture where it was developed. I hope this is clear to all. This distinction should be clear to everyone. We are going to study what JVM exactly does and how it is going to happen. So let us get let us unroll this JVM and the operation of it internally. Okay. So before that, let us see where do you write the Java code. So we are going to write the code in some editor. Okay, and we actually are going to use Eclipse or NetBeans or BlueJay. These are open source tools, editors, complete toolkits available for us. These are the development toolkits available for us. And if you are a new person, then if you install Eclipse, okay, if you download and install some version of Eclipse for your machine, then in that you are going to, everything will come along with it. So you will be given a development platform plus a Java runtime environment and plus an editor. Okay, so it becomes very easy for you to organize, write, debug your code and check it out. So better use some editors to write the programs in for your labs for all the assignments. Okay, you are aware of these names? Are you aware of these names? Can you let me know on the chat? Are you aware of Eclipse? So please download Eclipse. You might be using it for your C++ and C also. Similarly, you download it for Java, or the same Eclipse can be used if it is there already installed for your C++, can be used even for Java. Okay, so you just check. You should have JRE and JDK installed. Okay, and then yes, already downloaded, then very good. So make sure that you have one of the editors to write all your programs, implement all your programs in this lab, whichever you are comfortable with. But usually in exams, we provide you with Eclipse. Okay, so in exams, you will find Eclipse already installed on the PCs where you're going to perform your lab and you're going to give your exam. Okay, so what is your first Java program? Of course, it's going to be an Hello World program. Let us look at each of the words that you see on the screen. Okay, let us get into understanding what each of the words mean. So here, this word class, this keyword class is used to, I'll just mute everyone. Okay. Yeah. So here this keyword class denotes that hello world is class, and everything in user, who is this? Can you please rename yourself with your complete name and mute yourself? I do not want anyone to mute themselves, unmute themselves. Okay. Yeah. So here the class keyword is used to everything in your Java program is going to be written inside your class. Even your main is inside your class, right? So here we create a class hello world, and in that we have defined a method, a main method, which is mandate for every program, and this is the starting point of execution. Okay, so your execution begins from this method. So this method is automatically invoked and execution begins. And in this you have all these modifiers, public, static, void, and these are the parameters which are passed to this main method. Now in this, strings and the array args is used to accept command line arguments. Note that a class in Java is with everything within the class is put in the curly bracket, and it is not necessary to end this with a semicolon. You can have a semicolon, or you may not have a semicolon. That's all absolutely okay. Now this public keyword is an access modifier which represents visibility. Public means it's visible to all. So main has to be visible to all, and it has to be made as public. This specifiers are similar to what you have studied in C++. Okay, public, private, protected. In this, here you have public and private, and then this public specifier says that this method can be accessed by everyone. Okay, it is not, the access to this method is, the call to it is not restricted. Now every object, so for every class you create an instance. Okay, you create an object. In C++ also we create an object, and with the help of that object you call the methods of the class. But is it required for a main to? No, right? So for main it is not necessary that you create an object every time and then you invoke the method main also with the help of object. So this static this keyword static makes the method static. Okay, we declare a method as static with the help of this keyword, and after you do that there is no need to create an object to invoke this particular method. Okay, and then this method is directly invoked and executed by JVM. Okay, and we do not require additional memory or any additional objects to be created to invoke this method. Void is the return type of the method because it is not returning anything. You do not return any value here. Main is the starting point of the program. Strings, args is a command line argument, and you can move this bracket from here to here. It's allowed. Okay, it means the same. You're going to create an array of strings. System.out.println. So if you look at this statement, we have seen printf in C, we have seen cout in C++. Now this is what is there. This is how you print something on the console in Java. Okay, so you're going to have system.out.println. Now what is all of it? Okay, so system is a class, out is an object of this particular print string class, and then println is a method that we invoke from the print string class. And then whatever you pass as an input to that method is mentioned in the double quotes. Every statement is similarly terminated with a semicolon. So it is similar to other programming language with respect to all the other syntax of it. So we can change the sequence of modifiers. Okay, so okay, of course, this return type of the method has to be written immediately after it. But these modifiers, static, public, okay, you can change the sequence of it. That will not create a compilation error for you. Okay, so here even this string argument arrays can be passed in written in this different ways, as you can see it on the screen. So the bracket can be placed here or with the in front of the name of this array or after the name of the array, and so on. Okay, for this you should have some specific version, and then you can even put 3 dots to specify this where args. Now this I already spoke about. Having a semicolon is a optional thing after the class to terminate the class in Java. Now all these are the valid main method signatures in Java. You can use any one of them. So if you look at it carefully, okay, why the return type of the method has to be always along with the method name, and the sequence of modifiers can change. But if it is a main, then it has to be public and static in Java. Okay. If you try to remove one of them, then it will give you an error. If you remove static, if you remove public, it will create a problem. It will create an error. And here also, if you try to change the sequence this way, taking away void and change this considering void as a modifier, then even that is an error. You cannot even make it as an abstract method in Java. So all these are invalid methods. So why I am showing this to you? Because your exams can be in an MCQ format. Okay. So when the exam is in the MCQ type, you can be asked that which one are the valid, which one are the invalid. So keep trying different things and try to explore as much as you can, students. Okay. Okay. So to wrap up, Java is a high-level object-oriented programming language, and it is platform independent, which is developed by Sun Microsystems by James Gosling. It is considered to be both compiled and interpreted. Okay. I hope these 3 points are clear to you. We are going to still discuss more in this again. Okay. So final keyword, we will be discussing Tanmay. Okay. We will be discussing it ahead as we proceed with the course. Okay. So I'm going to continue. We have time. Okay. So I'm going to continue. Give me a second. Okay. So in C, suppose you write a code in which you have two methods and two method calls F1 and F2. And suppose these two methods are again written in two different programs, P2.C and P3.C. So after you pass all of this to the C compiler, it will create three separate object files. Now what is there in this object file? This object file p1.obj, p2.obj and p3.obj are going to contain your machine specific object code. That is what we call it as an object code, machine code. Okay. Now then all these three separate files are passed to the linker, and then linker creates one exe file. It links all the three files together, and then it will create one executable file a.exe or a.out in the Linux system, and then this exe file is then loaded in the RAM with the help of a loader, and then it is executed. Okay, so there are a lot of things to be linked. Okay, there are a lot of symbol table resolution, everything which is done by the linker, and finally after so there is a linking which has to be created to the library, the methods in the library, the call to those methods in the standard libraries, etc. Okay, so it is not just about this F1 and F2 in two other files. Along with it, the job of linker is also to give references to all such method calls which are being done in your program, and then everything is linked together, all the references are resolved, and then this one executable file is loaded with the help of loader into your RAM, which then runs. Now what is the same process followed in Java? Let us look at it. Suppose you create another same program which is written in Java programming language this time, and you save it as p1.java, in which you are going to have two method calls again and written in two different source files, p2 and p3. Now the Java compiler is going to compile them and create three separate class files. Okay, p1.class, p2.class, p3.class, and all these three class files are going to have bytecode into it. Okay, so the Java compiler creates class file which has bytecode. Remember, C compiler creates an .obj file which has machine specific object code into it. Okay. Now, after this, linking is not done in Java. Then what happens? All these three class files are then picked up. So Java has a runtime environment. Okay. So these three class files are ready, which is having bytecode into it. Now take them to any platform where you want to run it. So wherever the Java program needs to be run, we should have Java runtime environment on that system. Okay. Now inside this Java runtime environment, we have Java virtual machine, which is a program running on your RAM. Okay. It is a specification which runs on the RAM. Okay. This itself is a program. It's a virtual machine. Okay. It's a program which is running, which takes some inputs and, performs some actions, and then you see the output. Right. It itself is a program. So this Java virtual machine has a component called as class loader, which loads all the class file onto your RAM. And then there are different components of this Java virtual machine like bytecode verifier, which verifies that all the content of the class files are not violating anything, okay, any constraints. And then there is an execution engine, which actually picks up the bytecode, converts it into the machine code, and then runs. Okay, the execution engine can also take help of just-in-time compiler, like I told. Okay, so execution engine can either do the job of interpretation, or it can use a one-time compilation of the entire bytecode into the machine-specific code, and then it will get executed one by one, completely altogether, each instruction at a time. So here, I hope this difference is now clear to you. Okay. So what I want to highlight here is that this P1.class, P2.class, P3.class, whether it is created on any of the operating system, the bytecode generated remains same. Be it on Windows, be it on Linux, be it on Mac, this P1.class, P2.class, P3.class remains same. What will remain different? Okay, so this bytecode is then taken to a running environment. In this running environment, you have a Java virtual machine. Java virtual machine is machine specific. Java virtual machine is system specific. JVM is platform dependent. It is not platform independent. Without a Java virtual machine on your system, you won't be able to run the program. This Java virtual machine then takes up the class file or the bytecode, converts it into whatever specific machine is there on which it is running, and then the execution happens. Okay, so I hope this part is clear to you. So JVM is machine specific. So there is an additional layer which is there in Java which does not exist in C or C++, and this is what makes Java machine independent or platform independent. Okay, so JVM is platform independent. So when you are actually installing it, when you download JRE, JRE is a runtime environment which you require. Without JRE, you won't be able to run the program. JRE is that code. Okay, when you run the code, an instance of JVM is created, and inside JVM, your Java program is running. Okay, all your class files are loaded, entire code of all the method and all the codes are loaded, and then the program execution happens inside JVM. So JVM itself is an instance which is running. It's a program instance. Okay, it's an instance of a runtime JRE environment, which is having all the libraries and tools required to run a Java program. And then this is machine specific. This is going to be machine specific. So looking at what laptop or desktop you have to install JRE specific to your platform. It's a runtime environment. Okay, so that is going to be platform dependent. And then this JVM converts the bytecode to your platform specific code. It takes care of that after you have installed a platform specific system or platform specific runtime environment on your laptop. Okay, is this clear? Or if you have any questions, you can put in the chat box. This part needs to be clear to everyone, and I hope there shouldn't be any doubt in understanding what makes Java platform independent. Okay. So how is the Java architecture? So in your Java architecture, you have all these different components. Okay, students, you have a class loader. Okay, so this complete Java runtime system you can see right now on your screen. So let us try to understand each of the components into it.
Am I audible to everyone? Am I audible, students? Can you please reply? I think I got
Yes,
it.
ma'am.
Yes.
Okay. Okay. So I'll continue. So here the class loader is a subsystem of Java Virtual Machine, which is used to load the class files in your RAM. Okay. So whenever we run the Java program, it is first loaded by the class loader, and likewise there are three built-in class loaders in Java. The next that you see are the different memory areas allocated by Java Virtual Machine. Okay, so the complete memory is again divided into class area, heap, stack, PC register, and each of these different compartments are used for a different purpose. Say the class method area stores every per class structures, such as the runtime constant pools, whatever are the fields or the data members of your class. The complete code of all the methods inside the class is stored in the class area. Now the heap memory is a runtime data area in which your objects are allocated. So whenever you create an object of a class, it is allocated from this heap section of your memory in the JVM. Okay. Now in your stack, you store frames, something called as frames in Java. Okay, it holds all the local variables, the partial results, and it plays the most important part in the method invocation and the return of a method call. Okay, so each whenever a method is invoked, method means a function. Okay, whenever a function or whenever a method is invoked in a Java program, a new frame is created for it in the stack memory. Okay, and whenever the a method is completely executed, okay, then that time this particular frame is destroyed. Now for every method inside a method frame, what all do you think must be stored? All the variables, the results, etc. Right? And then in this case, each thread which is created by a Java program is also again allocated in the stack memory. So for every method invocation, there is something called as a frame which gets created in the stack memory. And in this frame, all the data or the control related to that method call is stored. And after the execution of the method is over, that frame is deleted from the stack memory. Now, PC register is a program counter register which contains the address of the Java virtual machine instruction which is being currently executed. Okay, so whatever instruction is being currently executed, that register holds the address of that instruction. And then we have native method stack, which contains all the code for the native methods which are used in the applications. Okay, then we have an execution engine in which you may have an interpreter or a compiler. Now, the job understand, read in detail letters also the difference in an interpreter and a compiler. An interpreter actually reads a bytecode, okay, and then converts it and executes the instruction. A compiler, this the interpreter does for every instruction, one by one, one by one, one by one. But the job of the compiler is picks up the entire code, compiles it entirely into an executable, then picks up the executable and then starts executing it. Okay, so Java also has something called as just-in-time compiler, which has more functionality apart from what I'm just saying. Okay, so in this execution engine, you have either, which is a virtual processor actually, it has an interpreter and a compiler both into it. And then finally, what you see is a native method interface. And in this JNI, Java Native Method Interface, is a framework which provides an interface to communicate with other applications which are written in other programming languages like C and C++. Okay, so Java also uses this framework to send output to the console or to interact with the libraries in the operating system. Okay, with the operating system libraries, if your program wants to communicate, then that communication happens through your native method interface. So that defines our Java runtime system. So what you have understood, I hope, that Java is a Java JVM, your Java virtual machine, is called as a virtual. This word virtual exists because it is an instance which is running in the RAM. Okay, there has to be some code which then executed in your memory, right? You write a code that is a physical files which exist. So JVM is not a physical file which exists. It is a running system. It is a running machine. Okay, that's why it is called as a virtual machine. Okay, it's a running program on your RAM, and it is a specification which provides runtime environment in which your bytecode can be executed then. Okay, so whenever you use that Java C command, your program gets converted to a .class file, on which you then run that Java command, which creates an instance of JVM, and then your program gets executed. So JVMs are, yes, it is platform dependent. I hope this part is clear to you, and it performs all of this following operations that you see on the screen. So we just saw that it provides definitions for memory area, different classes, registers, and it also has a heap and a garbage collector into it. So all the memory which is not being presently used, the job of the garbage collector is to free that memory so that it can be allocated for something else coming up in the execution. Okay. Now, Java Virtual Machine is the runtime system which is actually machine which is running in execution in which your bytecode runs again, right? What is JRE? What is this Java runtime environment? Now Java runtime environment is the implementation of JVM. Okay, there has to be some implementation which then runs on the RAM, right? So Java runtime environment is the code, is the software tools and libraries and all the files together makes this JRE. And then this JRE is nothing but the all the code that physically exists, which provides a runtime environment, which is then run and then creates a runtime environment. Okay, it is an installation package which provides environment to only run. So if you do not want to write the code on your own, and you're not a developer, you're just on a machine where you have to run a program, then just having JRE on that system is enough. You need not have any other development toolkits. So if that system or that machine is only being used to run a Java program, that having installed JRE on it is sufficient. Okay, why? Because once you install JRE, you have created a runtime environment inside, because when that JRE is running, your Java virtual machine is actually there on the RAM, which takes care of all the Java program and the bytecode being run into it. Right? It provides the execution environment to you. But if you want to develop, then you should download and install Java Development Kit. Now, what is Java Development Kit? It contains both the code for Java runtime environment. Okay, so it is both Java virtual machine plus all the library classes along with the development tools required, like an editor, everything into it. Okay, all the development tools which are required, complete package gives you Java development kit. Okay, it provides an environment to both develop and execute Java programs. So I hope you understood the difference between JDK, JRE, JVM, and all of them. Okay, so try to read it on your own also again, and be sure that this distinction is very clear to you. Just give me a minute. My phone is running out of battery. It will just get switched off in a second. Let me put it to charging. Yes. Okay. Sorry for the interruption. Fine. So I'm almost done with it. We won't begin coding today. Try to make your understanding clear on this part. And if you have any questions, you can ask.